Such access I have, such admin access over this Zoom room. All of you must be so impressed with my features that I can control here with my fingertips. All right, cool. So we're recording and I'm going to begin sharing the slides, this keynote here. Tonight, we're going to talk about coercion and truthiness. All right, so what are we going to learn about? I like to also call this the stuff that you can Google if you like Googling after class and you want to type in some key terms into Google to find other sources or hear what other people say about this. This is what we're going to learn. So we're going to learn explicit coercion. We're going to learn implicit coercion, which includes concatenation and the loose equality operator. We're going to learn how to coerce to a Boolean, which is also called truthiness. When you coerce one data type, like a string or a number or anything else, into a Boolean, that evaluates what's called the truthiness of the data type, of the value, right? Booleans are a data type which only have one of two values, right? True or false. So if you're tracking how a value is going to coerce, going to change into and become a Boolean, you are tracking its quote unquote truthiness. So we'll learn which values are truthy and which values are falsy. We'll talk about conditional expressions. We'll talk about the not operator, and we'll talk about logical operators. Yeah, real quick, does everybody know like data types and Booleans? Are those familiar terms for everyone, or would like it be helpful if I talked about them a little bit?
I'm good.
Could you please talk about them a little bit?
Yeah, for sure. Absolutely. So a data type, right? Data is like information, right? And a data type is a type of information. So a type of information might be numbers or strings, words, right? It also might be things like Booleans, which are a data type which is specifically true or false. I like to think of data types a lot of times like what you could put on a form, right? Like if I gave you a form to fill out and I gave you a questionnaire, all of the different types of questions that I could ask you, like multiple choice or like I don't know, your age, your name, stuff like that, all of that would fall under different data types. So the true false question, like, are you here right now? Yes or no? That would fall under the Boolean type. Yes, you are, or no, you're not. True, you are. False, you're not. Did that clarify? Is that enough of an explanation, or would you like me to try again?
No, that was great. Thank you.
Great, awesome, glad to hear. Cool, all right, so with that overview set in place, we're gonna go on into explicit coercion. So explicit coercion occurs when the type of a value is changed to a new type. So explicit coercion happens when we use one of the built-in global objects. So there are these built-in global objects that if you pass in a value, it'll create a new data of that type of value. So like for instance, here on line 6, we start off with num, which is equal to 10, which is a number, right? And then we console log out type of num. What is the type of num? It's a number. Then we go to line 9 and we say let's string, so we create a new variable and we pass num in to this built-in global object string. It's also known as a constructor. It like constructs the value. It constructs the value of that data type, right? I like to think of it as like, I don't know, like a watchmaker or like a a contractor, someone who has the right bricks and the right materials to build a string. You give them the request, you give them like what they should start with, and then they turn that into something else. So that's exactly what's happening here. We're explicitly going to the string constructor and saying, string constructor, please construct me a string out of this number. String constructor says, you got it. It creates a string with a value of, can I type on this? Yes, I love it. That's what the value is now. Before, it was just the number 10, and now it's a string, and the characters are 1 and 0. And if we print out the type of, what kind of data type is string, yes, that's the variable. Sorry. What kind of data type is this variable string? It is a type of string. Now that was a lot of words, and this is the first slide of my presentation. How are we tracking so far? Does that make sense?
Yep.
Yeah? All right, awesome.
Yep.
Cool. All right. I need your validation. That's what it is this class is just about me seeking validation in my ability to explain code. No, I sincerely want everyone to be able to like understand. I slap myself on the wrists when I'm at work and I don't understand what they're saying and I get lost. And then I walk away and I'm like, oh, you know, I just online shopped the whole time or something like that. And I blame the instructor later. So I don't want anyone to come back and not understand things because I was going too fast or inadequately described such and such thing. It doesn't sound like that's happening. It just sounds like I'm ranting, which I will stop doing now. Explicit coercion, another example. Coercion occurs, right, when the type of data is explicitly changed to a new type using a constructor, using a built-in global JavaScript thing. So here we have a second example. We have a string, which it has a value of 1000. If I print out what is the type, what is the data type here? What is the data type of string? We'll see that it is a string. Now I'm going to go to another constructor, the number constructor, and I'm going to say, number constructor, please give me a number. Here is the string that you can base the number off of. I pass in the string 1000, and I'm going to get a number, and the number is 1000. If I print out what the type of num is, it's 1000. Right? So we're explicitly asking, we're using stuff in JavaScript to explicitly ask for a change in data type, for a new value to be created from an old value. Implicit coercion. Implicit coercion also changes the type of a value, but unlike explicit coercion, implicit coercion is something that JavaScript just does for us behind the scenes. This behavior can be really helpful, but it's important to understand how it works so that we can anticipate what our code will do and we won't be surprised when it happens. So there's two examples here that we're gonna show about how implicit coercion happens. The first is with this plus symbol, right? And this process is generally known as concatenation. So concatenation, what is concatenation? Is when I have two strings and I put this plus symbol between them, what it will do is JavaScript will smush these two strings together so that I'll come up with a new string that is 1020, right? So that's concatenation. It happens when we're adding strings together. So here on line 5, I have an example where I'm creating a variable, not sure, and it's going to be equal to concatenating the number 10 with the string 20, with a string rather 20. Will this throw an error? return value. What's going to happen, Brendan? Well, I'm going to tell you. What happens is that behind the scenes, JavaScript looks at this value, it looks at this value, and it says, okay, I'm supposed to add these two together, but this 10 is a number and this 20 is a string. What I got to do is I got to change one. I got to change one into something else so that they'll be the same type. JavaScript says, well, you know what's easier than trying to create a number from a string? Creating a string from a number. So I'm going to go in here and I'm going to change 10 to the string 1, 0, and I'm going to then concatenate them. So just to run through what we get from these three, we have sum, which adds two numbers together. If I print out the value of sum, the new value is 30. If I do a concatenated string, right, it's going to be 1020. And then this not sure, the value is going to be 1020. We flip 10 into a string, and then we crash the two together. We concatenate them. Where does 1020 come from? Note that it's the same value as concatenating 10 and 20. So this just follows up on what I just said. The plus operator will implicitly coerce a number to a string if you try to quote unquote add it to a string. So we have another example here. We're creating a variable will be a string, and we're saying, okay, I want the value to be 10 plus the number 20 plus 30 plus 40 plus 50. Does anybody have a guess of what the value of will be a string will be?
Just 1 0 2 0 3 0 4 0 5 0.
Yes. I'm gonna take a guess that you didn't see the answer beforehand and that you answered that because of your knowledge of the concept. Yes, that's exactly right. That's exactly right. All right, quickly, I'm going to come down here and I'm going to delete this. Nobody look. All right. So here's another example. Line 7, we're creating a variable, also a string. This is a little bit of a tricky one, but it's 10 plus 20 plus 30 plus 40 plus 50. Does anybody have any guesses?
Is it 150?
Really close. It's yes, it is 150. It's really close is exactly right. Yes, it's 100 and then 50. What happens is we add this number to this number. That's 30. Those are two numbers, right? Then we add 30, so that's going to end up being 50. Then 40, that's 100. So this right here is 100. And then we add 100 to 50, and we get 100 and then 50. Yeah, does that make sense? Does that track?
So it just I guess the position of the string matters when you're concatenating.
Yes. Yes, exactly. What JavaScript will do is it will try to add things together starting from the left and going to the right. So if I had 30 here, this would end up being a string 30, 30, 40, 50, something like that.
If the last 50 were a number and not a string, would it be 90 or would it still be 50 because it hit a string?
You're talking about on this specific example here?
Yeah.
Ooh, I think that it's 90, but you know what, class? I don't know off the top of my head. So what I'll do is I will go to my REPL. Because full transparency, I don't know a lot of things. And I use the internet frequently to see what happens to stuff. So we said console.log 10 plus, I think we said 10 plus 20 plus 30 plus 30 was a string, plus 40 plus 50. I think it's going to be 30, 30, 40, 50 is, now that I look at it, I think that's what it's going to be. Yeah. Yeah. So what happens is that this becomes 30 and then we add this to this. So it's 30, 30. And then we're trying to add 30, 30 to 40. We don't skip ahead and add these two together. It's not like in math where you add things together and then subtract things and then all that business. You try to do things from left to right in the order that they're presented. Really great question. Any other questions about this example? Cool. Awesome. All right. Another form of implicit coercion is this double equals operator. This is a JavaScript. If you know other languages, or if you come across other languages, this is the way that other languages will equate two different values. Is this string equal to this string, or whatever? JavaScript is a little bit different. I won't bore you with the history of why this was created, but JavaScript has two types of equality operators. Equality operators, is that a term that is understandable, or would anybody like me to clarify?
No.
No? Good? Okay, cool. Are these two things equal? So JavaScript has the double equals and the triple equals. Triple equals is more common. It's what I use all the time. I don't think I really ever use double equals. Triple equals is evaluating whether or not the thing on the left is exactly equal to the thing on the right. Are they the same value and are the same type? Double equals will say, okay, I'm wanting to know if they're the same value, but I don't care if they're the same type. I'll do some JavaScript magic underneath the hood in order to figure out if they're the same value, even if they're not the same type. So a lot of people say avoid using the double equals operator because it has a large set of rules that it follows in order to like coerce values and figure out if they're equal without them being the same type. But they're kind of wild and you'd have to know a lot of things, which I am not interested in knowing many things. I've learned about myself. So I use the triple equals. Here we have an example. Is the number 10 equal to the number 10? Yes, right? That makes sense. They're the same thing. Is the number 10 equal to the string 10? True, yes. Those two things are equal. If you change 10 to a string, then they would be the same value. Here's where we get a little weird. Number 6, is the string true equal to the Boolean value true? False, they're not the same. Is an empty string equal to false? True. And finally, is the Boolean value true equal to the string 1? True. So what JavaScript does behind the scenes is it coerces a bunch of values, a bunch of types from one thing to the other. You will not have to know this. This is kind of just an example of how JavaScript like coerces things and can change types implicitly. Any questions about this?
Why is the third one false?
Why is the
in
third
this
one false?
instance?
You're going to kind of learn in a minute here, but remember
Got
when
it.
I talked about, yeah, no worries. remember when I talked about truthiness? An empty string is a falsy value. So it will coerce to false. Was that the one you asked about, or did I miss?
No, why is true, like the string true?
Oh, gotcha.
And
yes.
then like, why is that false when wouldn't the string true be true because it's not empty?
Yeah, that one I don't know.
Okay.
That one I don't know enough to guess about. That one's a deep rule that I've never learned, nor has anyone been interested enough to teach me. And I will not teach you it now because I don't know. But great question. Google is out there if you're interested. Cool, awesome. Moving along. Boolean coercion, truthiness, this thing I've been saying all night. What is it, Brendan? Tell me. Okay, I will. Values can specifically be coerced to Boolean values too. And when we're dealing with Booleans, we start to talk about a value's truthiness. So here's an explicit coercion, right? I'm going to the Boolean constructor here on line 3, and I'm saying, Boolean constructor, give me a new Boolean. I'm going to pass in this string, I am a string, and I'm going to get a Boolean true. Right. So really how we're determining whether like what the value, what the result of passing in this string is going to be is that string that values truthiness, that values behavior according to a list of JavaScript rules around which values will coerce to true and which values will coerce to false. When coercing a value to a Boolean, JavaScript uses rules to decide if a value should be coerced to true or false. Values coerced to true are called truthy values. Values coerced to false are called falsy values. So we have truthy values and falsy values. Most values are truthy. So strings with any length are truthy. Any non-zero number is truthy. It'll coerce to true. Any array will coerce to true. It's truthy. Any object is truthy. So you can see here that I create all of these different types of Booleans. And then up here, I'm printing out what the result is, what the Boolean it created is. All of them are true. These are the specific and only falsy values. Empty strings are falsy. 0 is falsy. The value null is falsy. Undefined is falsy. And non, which stands for not a number, is also falsy. Okay, so we also have conditionals. Conditionals are another way of evaluating a Boolean's truthiness or coercing a Boolean to a true or false value. This if statement, right? If statements check to see like, hey, if this thing is true, do something. If it's not true, do something else, right? So we can put expressions, we can put all sorts of things in between these parentheses, and the things in between those parentheses will eventually evaluate to either true or false in order to meet this if-else situation here, right? So here we have an expression, is 5 greater than 0? That coerces to true. It's like JavaScript goes in while the code is running and goes, okay, true, move on. If it was something like this, it would come in and say, okay, false. I don't know. That's the way I like to think about it, but it coerces to a true or false value. So here we have a conditional expression that's just taking in a string right? Without looking at the top right, can anyone take a guess at what this code will print out?
In the if.
Yes, exactly. Apples is a string with a length. Strings with any length are truthy. They coerce to true. So JavaScript comes in here while we're running it and says, okay, cool. Change that to true. And then if true, yep, go ahead and print this out. JavaScript will implicitly coerce the result of an expression in a conditional to a Boolean value anytime you see these if statements, right? So if 10, that's truthy. If 0, that's falsy. So in the first one here, we end up printing out yes. And in the second one, if false, it's not false. Go down to else, print out no. Okay, the not operator coerces a value to a Boolean value that's the opposite of its truthiness. That's why it's called the not operator. So it's like it flips this value to its opposite. So not true is false. Not, this is a truthy value, right? So not true is false. This is true, so not true is false. Arrays are truthy, so not arrays are falsy. Objects are truthy, so not objects are false. Yeah, does that track?
Yeah.
Yes.
Yeah. Okay. So what if we had some false values? What if we had, or even what if we did a double not operator, a not? It's not true, right? That's true, right? If something is not true, just like in language, it's true, right? It kind of like flips this to false and then flips it back to true. This is a truthy value. It flips it to false and then it flips it back to true. This flips to false, flips back to true. Does that track the not operator?
Yeah.
Yeah.
Yes.
Okay, good deal. Yeah. So so there you have it. So far we have not operators. We can pass in values into if statements and it will coerce to a Boolean value. So now we can use truthiness in order to get values with logical operators. So logical operators do two things. If you use them in something like an if statement, where that if statement needs to coerce to a single Boolean value, right? Like this needs to either be true or false. What it'll do is it will say something like and. Is 10 truthy? Does this coerce to true? And does 20 coerce to true? I could also use it for something like, is 3 greater than 1 and is 5 greater than 3? Both of these expressions have to be true in order for the entire thing to be true. Yeah. There's also an or operator that makes it so that only one of them has to be true. If this is true, the whole thing's true. Yeah, that's for things like if statements or anywhere where all of these, you're trying to coerce to a single Boolean value. Yeah, does that track so far?
Yeah.
Yeah.
Yeah, okay. Okay. So like here we have we don't have to use it just with expressions. We can use it with just single values too. So if 10 and 0, right? 0 is falsy. So this will end up being false. And it'll go to 0 is falsy, right? So you can use logical operators to combine expressions or pieces of code to combine them into one Boolean evaluation. There's also a way that we can chain together logical operators and get a value from them, right? Basically what I'm doing is I'm saying, hey, I want one of these values. Which one of these values will I select? And here's the rule. If you have a chain like this, and returns the first falsy value or the last value if all are true. So the way it works, I kind of like to think of it like a bouncing ball, like in karaoke, like bouncing along, and it's gonna change these. It's gonna evaluate their truthiness. If it's falsy, it's going to return. It's going to stop everything and store that value in return value 1. If it gets to the end and the last value is truthy, it will store that value in return value 1. So we're going to start at the beginning here. The bouncy ball is over 10. And remember, we're looking for falsy values first. So is 10 a falsy value?
No.
No, it's not. Okay. The bouncy ball moves to apples. Is apples a falsy value?
No.
No.
No, yeah. We're going to bounce over to 0. What about 0?
Yeah.
Yes. 0 is a falsy value. So it's kind of like I can get rid of all of this and do this, right? We return 0. Return value 1 has a value now of 0, right? What if this was 10? Does anybody want to take a guess at what return value 1 would be?
Null.
Yes, null. Null is another one of those falsy values. So it would bounce to 10, then apples, then 10, then get here and say, hey, this is a falsy value. So return value 2, right? We're doing the same thing. We're going to start off. Is lucky a truthy value?
Yes.
Yes, it is. So we bounce to the next one. Is number?
Yes.
Yes.
Yes. Is 7?
Yes.
Yes.
Yes. Okay, so then what's our return value?
7.
7.
7.
Yes. Oh my goodness. Yes, you all are so smart. So smart. Awesome. Cool. Yeah. So the first falsy, last truthy. Yeah. Okay. Then we have the or operator, and it's just the reverse. Or returns the first truthy value or the last value if all are falsy. So we're going to go right into quizzing you all. So we're going to start off here. Null, is that falsy or truthy?
Falsy.
Falsy. So we bounce to the next one. Undefined, is it falsy?
Yes.
Yes.
Yes, it is falsy. So we bounce to the next one. Happy.
Truthy.
It's true.
Truthy. Okay, cool. Do we bounce forward or do we take happy?
Take happy.
Take
Take
happy.
happy. Yes, yes. Return value 1. I know that it's up here, but I know that none of you are looking and that you're answering true to form. Happy. Yes, happy is stored in return value 1. Yes. So we go down to the next one. False. Is it falsy?
Yeah.
False
Yes.
is falsy. Yes. What about null?
Yep.
Yes, it is falsy. What about 10 is less than 0?
Yeah.
Truthy.
Truthy?
It's falsy.
Why is it falsy?
because 10 is not less than 0, so it would be false.
10 is not less than 0, so the result of the evaluation is false. False is a falsy value.
Oh, okay.
Yeah, good deal. Okay, what about non?
False.
Yeah, exactly. It's a falsy value. So what is our return value here?
Non.
Non. Yes, it is non. Awesome. So that's it. That's all the stuff for tonight. Explicit coercion is where we're going to use those constructors, right? Hey, string constructor, make me a string. Hey, Boolean constructor, make me a Boolean. Implicit coercion. I think I said coercion. Anyway, implicit coercion is done by concatenation, right? When we add a string to a number, or when we have that loose equality operator. Is 10 double equals to like the string 10, right? That'll change one value to a different type. And then we talked about truthiness. We talked about which values are truthy, which are falsy. Most are truthy. The falsy values are empty strings, 0, non, undefined, and null. We talked about conditional expressions, that if you have an if statement, or if you have a part of your code that is trying to coerce to a single Boolean value, you can put in different expressions. You can use multiple values to try to get them to coerce to a Boolean. You can use logical operators to combine them, right? And is if both are true. False is if just one is true. We talked about the not operator, which flips a value's truthiness to its opposite. So if it's a number 100, that's a truthy value. If I do not 100, it will give me the Boolean value false. And then we talked about logical operators, which are ways to string together chains of values and bounce down each value and try to return one of those values, right? And the rules are, if it's the and, it's the first falsy value, the last if all of the values are true, or operator is the first truthy value, the last if all of them are false. Yeah? Cool, cool. Does anybody have any questions over any of the things that we covered tonight? Cool. If you think of any questions, feel free to just hit me up on Slack. I'll be there. I'll be buzzing around on it all night.